Hey there, everybody. In this video, I want to go over computing probabilities from discrete distributions. And in particular, I want to look at how to interpret English words and how to get the probabilities based on those. So sometimes you'll just have, a description of what's going on, and you have to interpret that as a mathematical inequality. How do you do that? Well, we're going to do some practice problems here. Okay, so here we are. Consider the following probability distribution for shoe sizes for adult males. So here we have different shoe sizes, okay? And we have the probability that a randomly chosen adult male would have those shoe sizes. So we have the shoe sizes on the left, and they continue over here. And we have the probabilities on the right, and they continue over here. Okay? So it's the probability that a randomly chosen adult male will have that given shoe size. So the first question is, what kind of random variable is x? Well, you should realize that it's discrete, and it's discrete because you can list its values, and that's what I've done. I've listed the possible values for x. They are listed in this table from 6.5 to 15.5. They've been listed, okay? So that makes it discrete. If I can list all of the values, that means it's discrete. Now, suppose we choose an adult male at random. What is the probability that his shoe size is equal to 12? And perhaps we want to know, what is the probability that a shoe size is less than or equal to 9? Okay, how do we answer these? Well, what we do is we simply look at the distribution. So you can either look at the table for the probability that x is equal to 12, and it's written right here. So that's the answer, 0.107. Or you could even draw a graph of the discrete distribution, and the probability is given by the height of the bar that's above 12, right? And actually, when the bars have width 1, the height of the bar is the same as the area of the rectangle. That's another way to think about it, okay? So let's keep going with this. The other question we asked was, what was the probability that a shoe size was less than or equal to 9? All right, well, less than or equal to 9 means 9 or less, so we're looking at all of these values here. So we're going to add all of these probabilities. And when you add up all of these probabilities, you get 0.117. That's the same as adding up the areas of these rectangles here, or adding up the heights of these rectangles. Same thing. Okay? Let's do some more. Probability that x is greater than 14. Now, I invite you to pause the video each time I go through one of these. I'm going to go through them somewhat quickly, but you can pause the video and try to guess on your own, not guess, determine it on your own, and then we'll check your work with what we say together here. So x is greater than 14. Well, what does that mean? That means that we are to the right of 14 on the graph, to the right of 14, so it's 14.5 or more, right? And these are the numbers that are greater than 14. And so we're adding up these probabilities. When you add them up, you get 0.015. Okay, next one. X is greater than or equal to 14. So pause the video. What do you think that one's going to be? Greater than or equal to 14. Well, for that one, I'm not just greater than 14, but I could also equal 14. So I'm including that one. So I'm going to add up all of these. And the probability is 0.031, or the heights of these bars here. Next one, probability that x is less than 8. Well, here we have the numbers that are less than 8, that's these, add up those probabilities, or the heights of these bars. You get 0.011. Okay, what about the next one? Probability that x is less than or equal to 8. Okay, well, there it is. Less than or equal to 8 means it could equal 8, so we include 8. All right, so we're going to add in that probability. When you add up those, 0.029. Okay, what about the next one? Probability that x is, so that 10 is less than x, and x is less than 11.5. So try that one. Okay, here's what we get. So 10 is less than x, so x can't equal 10. But these numbers, 10 is less than these numbers, right? So these work. And x has to be less than 11.5, so we have to choose numbers that are less than 11.5, so we can't go that far. So these are the only two numbers that are possibilities, so we're going to add these two probabilities, 0.261. Next one. Go ahead and try that one. Let's take a look. It says 12.5 is less than or equal to x, and x is less than or equal to 13.5. Well, so we're looking at all the numbers that 12.5 is less than or equal to. Well, it's less than or equal to itself, and it's less than or equal to all of these. But also, x has to be less than or equal to 13.5. So it has to be 13.5 or less. So that's only these numbers. What are these probabilities? We add them up, and that's how we get our result. Okay, try the next one. 8.5 is less than x is less than or equal to 10. Okay, so if 8.5 is less than x, we're looking at all the numbers that have 8.5 less than them, so that's everything past 8.5. And x is less than or equal to 10, so x can go up to including 10, but it can't go past 10. So it's got to be these numbers. And so we add up these probabilities here, and that's how we get our answer. Okay, next one. 11 is less than or equal to x is less than 12. Try that one. Okay. Oops. Okay. So to say 11 is less than or equal to x means that we're looking at all the numbers that 11 is less than or equal to. So it's less than or equal to itself and everything past that. But at the same time, x is less than 12. So we can't go as far as 12 here. We have to stop here. So we're really only looking at these two values, or these two bars in the distribution. So we add up these probabilities, and that's how we get our answer. Okay? So that's it. That's it for this video. Just a quick run through. Oh, no, it's not. Sorry. It's not, because what I wanted to do was also look at words. That was one of the key things I made this video for. Looking at these words, okay? Because this kind of trips people up sometimes. So how do I interpret exactly 12? Well, that means that it's equal to 12. So here we are, exactly 12. It's just the height of that bar, or the probability corresponding to 12. What about at least 14? At least, what does that mean? Well, if I have at least that amount, that means I can have that amount or more, right? So I have these values. So I'm going to add up these probabilities to get my answer. What about at most 7.5? At most, what does that mean? Well, that means I can go up to that value, but not past it. So I go all the numbers up to 7.5, but not beyond. I can be at most that much. So I'm going to add up these probabilities. And that's my answer. What about the next one? No more than 7.5. No more than 7.5. Well, that means I can go up to 7.5. I just can't go past it. It's the same thing. To say at most and no more than, same thing, right? No less than 14. No less than 14. So I can't be less than 14. So what's that one look like? Well, that means you can be 14 or more. You just can't be less than 14, right? So we're going to add up these probabilities to get our answer. And then what about the last one? Between 10 and 11 inclusive. Between 10 and 11 inclusive. Well, here's what you should have gotten here. Between 10 and 11, well, there's one number that's strictly between them, but when they say inclusive, it means it includes the numbers on the boundary, 10 and 11. If they said exclusive, you wouldn't include those. Right? But inclusive means you include the numbers on the boundary. And so we add up these three probabilities to get our answer. And that is it for this video. Okay, so I hope you found that useful. I will see you in the next one.